Hello everyone, welcome back, and today we are looking at question 238, which is product of array except self. So we are given an integer array nums and we want to return an array called answer such that answer at index I is equal to the product of all the elements of nums except nums at index I. Now before we read these two lines, let's look at example 1 and see what's happening. So for instance, we have array nums, and this array contains the elements 1, 2, 3, and 4. As you can see, we have the output array, which is the answer array, and it's containing the elements 24, 12, 8, 6. So how they got these values? So let's have an empty array, and we will fill it out together to see how they got the output array. And this array right here is called the answer array. Now they are saying that answer at index I is equal to the product of all the elements of nums except at index I. So let's start at index 0. Let's go to nums and multiply all the numbers except the number at index 0. Let's cover out the 1. So 2 times 3 is 6, 6 times 4 is 24. Okay, good. Now let's go to index 1. Which means we will go to nums and cover the number at index 1. And now let's multiply the rest of the numbers. 1 times 3 is 3. Now 3 times 4 is 12. Now if we go to index 2, let's go to nums, cover the number at index 2, and multiply the rest of the numbers. 1 times 2 is 2, 2 times 4 is 8, and with the same idea, we would get the 6 right here at index 3. So this is how they are getting the output array. Now let's go back to these two lines and see the constraints that they are giving us in the question. They are saying that we must write an algorithm that runs in linear time, big O of n, and the most important thing is that we cannot use the division operation. Now why they are giving us this constraint? Now if they did not give us this constraint, the problem would be extremely easy. Now, why I say that? Let's look at this. We will have, like, let's say a variable is called product that will hold the product of all the numbers in nums. So product equals the product of all the numbers in nums, and I will write the expand form and will not write the final value to make the visualization easier. So this product will be 1 times 2 times 3 times 4. Okay? Okay, good. Now, when we go to nums at index 0, we said we want to multiply all the numbers except the number at index 0. In other words, we can divide by that number. We can divide by 1, and of course when we divide, these two will cancel out, and now we'll have 2 times 3 times 4, which is 24. Now if you want to go to the number at index 1, which means we can divide by 2. This and this will cancel out, and we will have 1 times 3 times 4, which is 12. Same thing for the number at index 2. If we want to get rid of the 3, we can divide by 3, and of course they will cancel out. 1 times 2 is 2, 2 times 4 is 8, and so on. So unfortunately, we cannot do this. We cannot use the division operation. And now the question also has a follow-up question that is saying, hey, can you solve the problem in constant space, big O of 1 space complexity? And they are saying that the output array, which is the answer array, does not count as extra space for the space complexity analysis. So the plan for today is the following. We will go to the blackboard, we will explain the intuition behind the problem, then we will solve the problem in big O of n time and big O of n space. After we understand and code that solution, we will go to the follow-up and we will adjust our solution and explain how can we get big O of 1 space complexity. If that sounds interesting, let's get straight into it. Okay, here we are at the blackboard, and we will start with approach number 1, where we will be using big O of n time and big O of n space. As you can see, I have wrote the nums array, and my nums array contains the values 2, 3, 4, 5, and at the bottom I have the answer array that we will return and that we will fill out together. Now, since we cannot use a division operation, let's start with some examples. Maybe it will help us see the pattern of the question. So I will start at index 0. Now remember that the answer at index I will hold the product of all the numbers in nums except the number at index I. So when we start at the field at index 0, this will hold the product of the 3, the 4, and the 5, and we are excluding the 2. So if we say, okay, we have the 3 times the 4 times the 5, I cannot see a pattern yet. Let's check the next index. Maybe it will help us more. Let's go to index 1. So let's go to nums and let's exclude the number at index 1, which means we are excluding the 3. So we need to multiply the 2 times the 4 times the 5. We can see that we have two sections here. We have the 2 and we have the 4 and 5. We can see that the 2 lies to the left of the number 3, and we can see that the 4 and the 5 lies to the right of the number 3. Now this is something we need to keep an eye on. Let's go to number 4 and to see what's happening there. Number 4 is at index 2, okay? So let's exclude the number 4 and let's multiply the rest of the numbers. We have 2 times 3 times 5. We have the two sections again, and now the 2 and the 3 lies to the left of number 4 and the 5 lies to the right of number 4. The same thing. Now this tells us that each number in nums, okay, have a left section and have a right section, okay? Now you might say, but what is the left section of 2, or what is the right section of 5? Well, let's have a look. Now coming back to the 2 at index 0, we can see that the product of all the numbers except 2 will give us 3 times 4 times 5. Now this is only the right section. Now what is the left section here? Well, we can put a 1 as the left section because 1 times anything gives you that value. So 1 times the right section. Now in case of the 5, we can say that the left section is 2 times 3 times 4 is the left section, and the right section would be 1, okay? So we can see that each number in the nums array have a left section and have a right section, and if we go to the answer array at index I, we go to nums at index I, we need to multiply the left section with the right section, and the value will be in the field of the answer array. Okay, how can we make this left and right section in an efficient way? Well, let's create an array for the left section and let's create an array for the right section. So let's do that. I have wrote the left array, and now this left array at index I will hold the product of all the numbers of nums to the left of index I. Now let's start with index 0, which means we need to go to nums and we need to multiply all the numbers to the left of the number at index 0. You can see we have nothing to the left of the 2, which means we can just put the value 1. Why 1? Well, because 1 times anything gives you that value. If you said why we can't put a 0 here, for instance, well, because 0 times anything is 0 and we will zero out everything. We don't want that. So to the left of the 2 we have nothing, we put the value 1. Now let's go to index 1. Let's go to nums. At index 1 we have the 3 and we need to multiply all the numbers to the left of the number 3. Well, we have only the value 2, so this will be 2. But you can think about it this way. 2 times 1 gives you this 2, okay? So let's continue. Let's go to index 2, and we see at nums of index 2 we have the value 4, and we need to multiply all the numbers left to the value 4. Well, we have 2 times 3, which gives us 6. Or in other words, we have 3 times 2 gives us 6. Now why does this work? Well, because look, if we need to multiply all the numbers to the left of the numbers 4, we have the 2 times the 3. But remember that this field holds the product of all the numbers to the left of this section. Now we can take all those values, the product of all those values, which is stored here, and the only thing remaining is this 3. So we can say, hey, take this value times the corresponding index in the left array. So 3 times 2 gives you 6. Now let's go to the index 3 and we see we have the value 5. So we need to multiply everything left to the value 5. Same thing, you can say, hey, 2 times 3 is 6, 6 times 4 is 24, and you just write 24 here. But again, this 6 holds the product of all the numbers left to index 2. So this 6 is the product of 2 times 3. Now what is remaining? Well, it's only this 4. So we can take this 4 and just multiply it by this 6. So now we just filled the left array. Now you can see that this left array, we can say that, hey, the left at index I equals what? Well, let's go again here. Well, we said when we need to fill out this, we said, okay, we need to multiply all the numbers to the left of, index 3. And we said, hey, we can take this and we multiply it with this. Because this 6 is the product of all the numbers to the left of index 2, which is the product of 2 times 3. And the only thing remaining is the 4 to get 2 times 3 times 4, which is 24, that we will fill out here. So the left at index I equals the left at index I minus 1, which is this, times the nums at index I minus 1, which is this. That makes sense. So let's code this section out quickly on LeetCode. I like to have the length of the array in a variable. I don't like to keep writing nums.length, etc. So let's have a length variable that will have the length of the array. So this length will equals nums.length. Now remember that we need the to return the answer array. So let's just make it. So we have the int. This array will hold integers and we will call it the answer equals new int. And now what is the length of this answer array? Well, it's the same length of nums. So we just put length. Now let's code the part that we just discussed. We have this left array that we need to fill out. So we have int, let's call it left, and the length of this array will be the same as nums, of course. So new int length. Now we said we need to fill out this left array. At each index, each field in this left array will hold the product of all the numbers left to the index at this field. So we will have for int I equals to 0, I is less than the length, of course I plus plus, okay? And now what? Well, we said we will have left of I will equals something. But before we continue, let me ask you something. As you can see, the value here is 1. It will always be 1. Well, why? Well, because there is nothing to the left of the first element. So the left at index 0 will always be a 1. So we can just write it from the start. Hey, the left at index 0 will always be a 1. And there is no need to start from index 0 now. We can start from index 1 because we took care of the case with index 0. Now we just say that based on this equation, hey, the left at index I equals left of index I minus 1 times nums at index I minus 1. So nums at index I minus 1. We just finished the left array. So let's continue now. Let me clear out this to have more space. And now we need to create the right array. The same concept here, but now each field in the right array will hold the product of all the numbers to the right of that index in nums. So let me create the right array. Okay, so here it is. And let's put this array in code, right? Because we need this right array. So let's make it. So we will have int, and let's call it right, and equals new int, and of course the length of this right array will be the same as the left and the same as nums, of course. So length. And now I like to organize my code. So let's comment what this section does. This section is basically saying, hey, fill the left array. So now we need to fill the right array. So now we can say fill the right array. So okay, so let's have a look. Well, we will do a very similar thing to what we did with the left array. Starting with this value 1 right here. Well, we put a 1 here because we said there is nothing to the left of the value 2. There is nothing left to the first number in nums. Now let me ask you, is there anything to the right of the last number in nums? Is there anything to the right of the value 5? Well, the answer is no. So by the same concept, we will always have a 1 in the last field in the right array. Now, in the left array, we started going from left to right because it makes sense. Now, in the right array, it makes more sense to start, from the right hand side going to the left hand side. Okay, so we just filled the value 1, and let's put it into code because we said we will always have a 1 in the last field in the right array. So we can say, hey, the last field of the right will always have the value 1. So, and arrays are 0 indexed. So we say the right of length minus 1 equals the value 1. Okay, so now let's go to index 2 in nums, and we want to multiply all the numbers to the right of index 2. We can see that we only have one value, which is 5, so we know that this will be 5. But by the same notion as we did here, 5 times 1 will be equal to 5. So let's go to index 1. We go to nums. At index 1, we need to multiply all the numbers to the right of index 1. We see that we have 4 and 5, so we know that 4 times 5 equals 20, but again, we can say that 4 times 5 equals 20. So now finally, let's go to index 0. Go to index 0 in nums, and we need to multiply all the numbers to the right of index 0. We have the 3, the 4, and the 5, so we know that 3 times 4 times 5 is 60, okay? Or in other words, 3 times 20 equals 60. Again, why does this work? Well, because when we go to index 0 and we need to multiply all the numbers to the right of index 0, we already have this value. And what does this value represent? Well, this value represents the product of all the numbers to the right of this section, which means the 4 and the 5. 4 times 5 is 20. And the only thing remains is this 3. So 3 times 20 equals this 60. So let's have this for loop. So we can say for int I equals what? Well, we already took the care of length minus 1. So this I will start from length minus 2, right? Okay, and we can say I is greater than or equal to 0, and of course I minus minus. And we can say, hey, the right at index I equals what now? Well, let's have a look again. If we are at index 0 and we said go to nums at index 0 and we need to multiply all the elements to the right of index 0, well, what we did is we went to this field, which is at right of index I plus 1, right? I plus 1, and we said we can multiply this by the value 3, or in other words, nums of 0 plus 1, or in nums of I plus 1. So nums of I plus 1. Okay, so now we have filled the right array, and finally we need to fill out the answer. And we said for the answer, at each field we need to multiply the left section with the right section, and we can see that 1 times 60 is 60, 2 times 20 is 40, 6 times 5 is 30, 24 times 1 is 24. So we need a for loop for that, and we can say, hey, now we need to fill out the answer array, right? So we can say for int I equal to 0, okay, and I is less than length I plus plus, and we can say that, hey, the answer at index I is equal to the left at index I times the right at index I. At the end, just return this answer array, so return answer. Okay, so let's run the code and let's submit. So now again, why is the time complexity big O of n, and why is the space also big O of n? As you can see, we have a for loop for the left, we have a for loop for the right, and we have a for loop to fill the answer. Well, this for loop needs big O of n, this for loop also needs big O of n, and this for loop needs big O of n. So in reality, the time complexity is big O of 3n, but we can drop out the 3, and the time is big O of n. Now, in terms of the space complexity, the question said you do not need to count the answer array towards your space analysis, but we can see that we created the left and right arrays, each holding the values of the nums. Assuming that nums have n elements, of course, the left needs big O of n space, and the right needs big O of n space. So the space complexity is big O of 2n, but we can drop out the 2, and the space is big O of n. Now let's look at the follow-up and try to adjust this solution to match a constant space, big O of 1. Okay, let's now look at approach 2, which is the follow-up question. Now the follow-up question wants a space complexity of big O of 1, which means we cannot use any extra memory, we cannot use any extra arrays. Now the question also said that the answer array is not counted towards the space complexity, which means everything we will do in this approach will be manipulating the answer array. So right from the start we know we cannot use this right and left array, so let's just delete them. Now in terms of the approach, we will do the same exact thing. We will still have the left section and right section, and each field in the answer will be the product of the left section with the right section, but now the implementation is different. Now we will do the implementation in 2 steps. Step 1 will be the same thing as this fill the left array. At each index in answer, we need to put the product of all the elements to the left of that index in nums. Literally the same thing as here. Honestly, I will just replace left keyword with answer keyword, and that's it. Literally the same thing. So answer of 0 will be 1, and now the answer of I will be answer of I minus 1 times nums of I minus 1. Now we have filled the answer array with the left product, right? So let me just write them down. So here we will have 1, and again, because we have nothing left to the number 2, so we just put a 1, and now we said here we will put 2 times 1 is 2, 3 times 2 is 6, 4 times 6 is 24. So this is step 1. So let me change this comment from fill the left array to step 1, which is same thing as filling the left array. So as the left array, same thing as filling the left array. Now let's go to step 2. Now we said that each field in the answer array is basically the product of the left section times the right section. So again, for instance, the index 2 in the answer array, here we have the final answer that we want to get. So at index 2 we have 30, which is basically 2 times 3 times 5. As we can see, we have the left section and we have the right section. At this point we have the left section, which is 6, 2 times 3. Now how can we find the right section? We cannot make an extra array for the right section, but now we will have a variable that will hold the product of the numbers to the right of each index in nums. We will continuously update this right variable to hold the product of the elements, to the right of the index in nums. Okay, so we will have a variable called right. So for instance, int right equals what? Now we said in the right array we want to start from the end, right? So we are starting from here. Okay, now, so in the answer array we have 24, and in the of course in the array that we want we also have 24. So what should we do now? What the initial value for right would be? Well, let's see. We said the right will hold the product of all the numbers to the right of each index. Now we are at index 3. So do we have anything to the right of the number 5? Well, we have nothing. And we said when we don't have anything, we put the value 1, right? So this right variable will start with the value 1. Now when we say 1 times 24 would give us 24. And now to make the code more organized, we said we don't have a right array, so this does not make any sense. So let's just remove it. We just have the answer array. Okay, now we said, okay, the right is 1. 1 times 24 is 24. And now we need basically to update this right. We don't want this right variable to hold constantly the value 1. So after we finished with this field, now before we go to this field, we need to update this right variable. But to what? Let's see. So we said now that the right is equal to 1. So now when we go to index 2, right, we have this 6. Now this is the left section of the 4, right? 2 times 3 is 6. Now when we go to index 2 and we need to multiply all the numbers to the right of index 2, we only have the value 5, and we can say 5 times 6 equals 30. But remember that we also have this right, and we said the right equals to 1. So what we can do is that, hey, the right will be updated to be right equals the right that we have times what? Times nums of I. Times nums of I. So right when we finish finishing this field, finishing this 24, we will update the right to be, hey, now the right will be 1 times nums of I. If we are at index 3, nums of 3 is 5, so 1 times 5 equals 5. Now the right will be updated to 5. So now what we can do is that, hey, right section times this 6, which represents the left section, 5 times 6 is 30. So now again we will update this. Hey, so the right now will be what? So the right is 5 times nums of 2, which is 4. 5 times 4 is 20. So now when we go to index 1, we can take this 20 times this 2, which equals to 40. And again, we need to update the right. And what we can do now is that, hey, now the right is 20, right? And nums of I is 3. And 20 times 3 is 60. Now when we go to index 0, we can say the right section, which is 60, which represents 3 times 4 times 5, times the left section, which is this one. 60 times 1 is this 60. So let's write the code for that. We said that the right will be initially 1, right? Because we don't have anything to the right of 5, so we can do that. So int right, we said 1. And now we will have a for loop, and we said we need to start from the end. So for int I equals length minus 1, I is greater than or equal to 0. So I is greater than or equal to 0, and we say I minus minus, since we are going from right to left. And now what? Well, we can say that we said the answer at index I is equal to the right variable that we have times answer at index I. Answer at I. Okay, and we said we need to update the right variable. Right equals right times nums of I. So right equals right times nums of I. And that's it. As you can see, now we only have the answer array, which means the space is constant, and also we dropped the time complexity. Now we only have 2 for loops instead of 3. So the time complexity is big O of 2n, we can drop the 2, and now it's big O of n, of course, and the space is constant. So let's run the code, and let's submit. And as you can see, faster than 100%. Thank you guys so much for watching, best of luck to you, and I will see you in the next one.